Hi guys, welcome back to my channel. And this is the day 5 of DSA Bootcamp, and today is 12th July and 2024. I will be starting with GFG portal and the problem of the day. And this problem was asked in many companies, as you can see, Amazon, Microsoft, Samsung, whatever, all the companies. It was one of the fan company repeated question, and I will be solving this. And let's dive into that. This falls under easy category, and let me start with the reading the question, understanding the question, and then we'll be following that. Yeah. And I will be teaching in my notepad so that you can understand in better. This is a day 5, and yesterday I have posted a lot more. Like day 1, you will see that day 1 to day 2 and day 3, day 4. Every day I will be posting daily solutions. Not only GFG, I will be posting the lead code as well. As you can see, everywhere lead code solutions also I will be posting. So please like and share and subscribe to my channel. And the question is root to the leaf path sum. From while reading the question itself, you can able to understand that we have to find the sum who's starting from root to the leaf, the particular branch whose value is equivalent to the sum. That's what the given binary tree. Binary tree indicates everywhere we have two childs. That's called a binary tree, which means two childs. And at, at, at at most, not every time, at most. And do your target and check whether there is a route to leaf path where its sum as S. S is nothing but a target. Here they will give a target and you have to find from route to the particular branch, only one of the branch whose target is equal to the given one. That's what have fun. And that is the base case and this is sample test case 1 plus 2 3 at anywhere we are not getting the required answer, so we can return false. Sorry. And if there is no part, we can return false. And here the target is 4. If you add this branch, we will get 4. So the word this one of the solution. And as per the time complexity, linear nodes traversing and this will be the height of the tree. And you can see 10 power 4 number of nodes. This is the constant and the target value is up to 10 power 6. And I'm deep diving into the solution. The expected solution is that whenever any three kind of questions given to you from the interview side, you can simply use BFS, BFS, or any recursions that will be solved. As with the tree problem, we are going with the recursive approach, and by taking, for example, here the sum is 5, the target sum. I will be starting with 2. I will be subtracting this sum to 2. You will get a 3, and I will check for the left side until we reach to the leaf node. If the sum is equivalent to the target, then I will be returning true. Else, I will be returning the false. Here you can see this particular trick is equivalent to the 5. And this is not satisfying because it is increasing the value. Here this is we are value. So we are not considering that. Whenever we are not just like we are doing that, we will get at the end of -1. At the end we will get 0 here. So when we are doing here, for example, 5 minus 2 we will have 3, and 3 minus 1 we will get 2. 2 minus 2 is equal to 0. We are getting. So whenever we reach 0, we can return true. At any cost, at any branch, we will get any true. So we can simply return and the final answer is true. That's what the question. And we can call subsequently, we can call to the left subtree, right subtree at any point. So when we are at, we can call left subtree first and then right subtree. The question always do until it reaches the one of it follows the DFS approach simply. Like until it reaches to the end, terminates the condition, it will go on particular direction only. Not it doesn't go to the opposite direction. Once it reaches, it will go to the other direction, other way. Okay, this is the approach. When we are moving from the top to left, we will be reducing the target sum to the current node value, and when we reach the zero, we are into same thing, calling for the left, reversibly, and here that calling for the right. And you can see that we are getting a target of 2, here also 2, and, and if you can see that if the left cell will return a false, if the leaf data is not equal to the target. That's what it was showing. And we are doing the logical OR operation, which means at any cost, at any branch, we are getting a target equal to 0, then we can simply return that true. And logical or true or false, we will get always true. If any one of the operation is true, then logical OR satisfies the true. Here the example, another example, target 6 we want, and this green color one satisfy that, and blue and other we are exceeding the target value, we are not considering, and we are returning the false. And this is the another output. You can see we want the target as is, and this is one of the brands. This is one of the brands. How we are following from top to bottom, from head to we are subtracting it. You can see sum as 5. We are separating 2. We are getting sum as 3. At the end, we are separating, and whenever we are reaching 0, we can simply return the true, and subsequently it will return the function called the DFS. The stack frame will be exhausted and reaches to the terminal condition. It returns the caller function. So it returns the caller function. One side we will get true, other side whenever we reach any null, so we can return false because there is no node. It will resultant value is 0, and yeah, it not satisfied the given target. Not false, not 0. So it was nothing there. So we can return false. And here also we are getting a target sum as -10, which is not taken up, which is exceeding the target, and we can return the false here. And logical operation for both, we are getting true. So we can simply return the true. This is a pseudo code taking the root and the target as S. And first of all, we need to check the root is null. If for the case, if the root is null, we can simply return the false. No need to go for the other iteration. And we have to check for the leaf condition. If root is doesn't null, how we can check that root dot left equal to null and root dot right equal to null. If the current child doesn't, if the current node doesn't have the left child and right child, that doesn't mean that it was a loop, it was a leaf. And we are check for the data. It's the data whenever the sum minus root data, if we subtract the value from the target sum, whenever we are reading 0, we can simply return 0, and else we can return false. And we are calling DFS function towards the left and towards the right by separating its the current value. By using logical OR, we will be getting an answer that will be written at the end. That's what we should do. Base condition, checking the subtree, and checking the leaf nodes and recursion, calling left and right chain, finally result. Where you can see same thing, what I have informed. If the node is null, check for the sum. If the sum equal to 0, we can return true or else false. And by default, we can store one boolean array, boolean value. Default value is on false, and separate the current node value to calculate the remaining sub nodes, and we are checking this up whenever we encountered any 0, and there is a leaf node. You can see left and right are in leaf, and we can simply show this is one of the branch, we can return that. As we have to check further if the left subtree exists, go to the left subtree, and at any cost, if you are getting the true, you store the answer and return back the answer. Same for the right side. For the right side, at any cost you are getting true at any function call, please remember. Uh, this will take order of so, and for time complexity, phase complexity is the height of the binary tree. That's your thing. And this will work for less number of test cases when the large number can for 1e4, it will satisfy. If more than one is 6 or more than one is 7, it will fail. Because of we will get stack overflow and 10 power 6 is the maximum stack it will be storing. So alternate approach, we have to communicate with the enemy, always use the without a recursion we should go. Because a recursion will always use heads up like auxiliary stack space it will take and more number of stack pods, so it will lead to the heap memory out of memory and heap space exhausted. You will get an error. Yeah. And the second approach is same, the simulating the above approach with the help of stack array. The data structure we are using stack instead of stack frame. We are using stack to store the current level and the current target subtracted value. That so you can see the current stack and the sum. Sum indicates the subtracted one. So initially we have to store the root data and root to traversing throughout the array, and this for the current cumulative sum, current sum. And we will be checking while we adding right simply BFS. It's kind of a BFS using a simulation with the help of stacks, two stacks, and we are popping the current root head and we are subtracting from it and going to the checking for the leaf condition. If it is a leaf and sum is equal to target, we found the answer, we can return that. As same condition. Same we have checked out. If it is a leaf and sum equal to 0, nothing but target, we are returning it. Same thing we have done here with the help of stacks, two stacks and left node and pushing those left node value and adding to the sum. Here, what we are doing, we are adding the sum and at the end we are checking for the target equal to the current running sum. We are checking. You can see that target is equal to current sum. But in previous class we are subtracting. That is the case. Whenever we are reaching 0, we are retaining that. That is a slight modification in simulation and we can achieve that. And this is faster, but it takes some additional space. Order of linear number of elements we have, that much time, that much space it will. Yeah, that's all. It's like space and such. Yeah, that's all.